Welcome, ladies and gentlemen, to Integrated Math 2. In today's episode, we will be discussing Chapter 3.2.2, which is connecting slope ratios to specific angles, which is basically a continuation of the last section. We are delving into our journey of connecting slope to angles of elevation. And in 3-78 here, it says, what do you know about this triangle and how it relates to other triangles we've seen? And we have to use any information to solve for y. In the last episode, we saw a triangle, and we determined that when it has an 11-degree angle of elevation, the slope ratio of the side that was opposite of the angle to the side that was adjacent to the angle was 1/5. This problem is asking us to use this information to solve for y. So what we can do is we can set up a proportion. I can say 5/20, if I go from small to large, is equal to 1/y. And I can use this to solve for the y. So I can go ahead and split this guy down. That's going to be 1/4 equals 1/y. If I cross multiply, I get y equals 4. So using a similar triangle proportion, I'm able to figure out the value of y pretty quickly, or the rise of that slope triangle. I'll be back with the next problem. In 3-79, we're supposed to determine the values of the missing pieces using our slope angle knowledge. And so from here, with part A, again, go back to the triangle notes that you had from the last lesson, and what we determined was that when you have a triangle that has an angle of elevation of 22 degrees, it was double the size, or double the slope of the 1/5, which was the 11-degree angle. So instead of 1/5, it ended up being 2/5. And so again, if I compare that to the triangle in A, which has the 22 degrees here, with this being 25 and this being y, I can go ahead and do that same ratio. I can say y/2, if I go from right to left, is equal to 25/5. And so from here, I can go and reduce that. I can say y/2 is equal to 5/1. If I cross multiply, I end up getting y equals 10 as my value. So again, I'm just using similar triangles here. And there's a reason why we did so many similar triangles before, and that's because we're eventually going to learn a relationship that allows us to determine this slope angle relationship here. So again, with B, there's our good old buddy, the 11-degree angle again. I'll go and call upon my stock triangle here. Whoops, that's not an X, I'm using that. So this is going to be 5, and this is going to be 1. Again, I'll just compare sides here, right? So x/5 is equal to 100/1. So I've got x equaling 500. Again, just a bunch of similar triangles here, So that's B. If you look at part C is this triangle here on the left side here. Now notice how the slope angle is 45 degrees. Now what we saw in the last parts of the last section was that when you had a 45-degree angle of elevation, the rise and the run were exactly the same, right? We saw that our base triangle here, and I'll go ahead and just draw this on the white space here. It had the slope being 1, which meant if this was 45, it had a rise of 1 and a run of 1, which makes this problem pretty easy because now A is just going to be 13 because of a similar triangle. Similarly to D, they want us to actually solve for the angle now. They're giving us a slope ratio of 4/4, so we're just going to use C backwards. It's got to be 45 degrees instead. Same thing with E. It's going to be the slope ratio backwards. So they give us the slope ratio. We got to find out the angle. Well, again, I can reduce those, dividing each side proportionally by 10, giving me a slope ratio of 2/5, which we determined earlier on was 22 degrees. F is arguably going to be the hardest one because 79 degrees is not something that we are familiar with. However, if I flip this guy on his head, on his back, for F, if I make him a triangle that looks like this, where this is now B and this is now 7 and this angle is 79, well, if this guy is 90 plus 79 is going to be 169, leaving you only with 11 degrees possible for this guy. So I'm going to go ahead and compare him to my 11-degree base triangle, which, oops, that's 11 degrees. So that's going to be a rise of 1 and a run of 5. So that means that I'm going to go 1 over 7 is equal to 5 over b. Cross multiply, b equals 35. So the hardest part about f was flipping the triangle down and recognizing the 11 degrees, even though it wasn't explicitly given. Hopefully that makes enough sense. Let's move on to the next problem, and I'll be back in a flash. And in the next problem, it says Sheila says the right triangle is the same as her drawing on the right. Basically, we did what Sheila did. And we basically did this, and it says use what you know about the slope of 11 to determine the slope ratio for 79. So again, we're just going to call upon that last triangle that we did. We flipped it on its head like this. And so with this guy being 7, this guy ended up being 35. This guy being 11 degrees. This guy being 79 degrees. Oops, 79 degrees. And it says it said use what you know about the slope ratio of 11 to determine the slope ratio for 79. So let's go ahead and flip him back on his head like we saw in part F. So that puts the 79 degree angle down here and the 11 degree up here. So from here, if I calculate the slope ratio of this triangle here, then what I'm going to get is I'm going to get the 7 on bottom and the 35 up top, which means the slope ratio of 79 degrees is going to be 35 over 7 or 5 or 5, right? But again, the slope ratio of 11 degrees is 1/5. So what they're trying to get you to see in part C here is that the relationship between their slopes is that their slopes are reciprocals of each other. Their slopes are reciprocals of each other. And again, this is all because of this angle. We get an angle, an opposite side, and an adjacent side, and eventually we're going to learn about the more intricate way of figuring out the ratio and the relationship between the opposite and adjacent sides and their angles. That will pretty much conclude this lesson. You'll be given a trig table at the end on 3-82 in order to fill that out. But for now, go ahead and copy down these notes and understand the slope ratios and their connection to angles. As always, please leave comments or questions in the comments area, and I will see you all in the next episode.